And we're back. Got ourselves a pacifier. I think we're ready. Okay, so here we have our graph, and we're looking at this function, and this steep point here, which in business terms is our point of diminishing returns, also thought of as our maximum rate of return, in calculus is called an inflection point. Now, the portion of the graph that is before that inflection point has this sort of half of a U-shape type shape, and that portion, that shape is called concave up. If I were to draw a picture of a graph that is concave up, it might look kind of like a U shape. Now, the portion of the graph that looks like up above here is kind of this second half, but this whole U shape is considered concave up. Okay. Now, if I were to draw some tangent lines on this concave up graph, some things that I notice are that every single tangent line is below the graph. In other words, the graph is above every tangent line. And so on any concave up graph, the graph is always above the tangent lines. Okay. On the portion of our graph in our function up here that we care about, in this concave up portion, this graph up here is increasing. Our function f of x is increasing at an increasing rate. Now, calculus-wise, as soon as I hear the word rate, I immediately think about things like instantaneous rate of change, and as soon as I hear instantaneous rate of change, I think about derivative. So increasing rate, well, that means I'm thinking about p prime of x. Now, if p prime is increasing, that means that p prime's derivative, so p prime is a graph meaning that the slope is going uphill, so slopes are getting steeper, the slope is increasing, its derivative will be positive. Now, the derivative of p prime is p double prime. So, or in this case, we're talking about the function f. So f prime is increasing because we have an increasing rate, and that tells us that f double prime is going to be positive. So any time that you have a graph that is shaped in this concave up U shape, the second derivative is always positive. So on this portion of our graph, our second derivative is positive. On the other hand, on the top half of this graph, we have this portion up here where our function is increasing at a decreasing rate. This shape up above here is considered concave down. Now, when I draw a concave down graph, or a concave down shape, that's kind of an upside down U shape. And if I were to draw some tangent lines on this graph, what I notice is that every single tangent line that I draw is pushing this graph down, and our graph is below the tangent lines. So our graph on a concave down function, the graph is below the tangent lines. Now, if I look at the portion of this concave down graph that kind of matches the shape on our original function over here, that's kind of the first half. And on that first half of the graph, our function, f of x, is increasing at a decreasing rate. So the fact that we have a decreasing rate, that tells us rate is our derivative, So f prime is decreasing, which means its derivative, f double prime, is negative. So anytime that you have a graph that is concave down, the second derivative is negative. So up here, concave down, f double prime is negative. So when you have this upward U shape, then our second derivative is positive. When you have this downward kind of an n, lowercase n type shape, then your second derivative is negative. Now, then you might ask yourself, well, what happens halfway between positive and negative? Well, halfway between positive and negative, or between negative and positive, is 0. So this inflection point, this steepest point that we have here, at the inflection point, the second derivative is equal to 0. And so we're going to be interested in finding these points of diminishing returns. And the way that we're going to be doing that is by looking at our function and figuring out the x value where the second derivative is equal to 0. All right, thanks for listening. Our next video is going to be an example of one of these.